This is a compact design for the CCi-MOBILE Research Platform. It has an onboard Wi-Fi module, a Spartan 6 FPGA, an audio input, RF output, headphone jack output, a micro USB port to connect with the PC or a smartphone, an audio codec, and a wireless switch for communication between USB to Wi-Fi. Now, let's take a look at a demonstration of the CCi-MOBILE working in real time. The electric-only board shown here is running a version of the Advanced Combination Encoder or the ACE strategy via MATLAB, a high-level programming language. When you speak into the behind-the-ear microphones, you can see the excitation of the electrodes from the coils on the RF decoder. The blinking LED shows which electrodes are being excited at any current moment in time. The RealtimeStimulator Demo is a MATLAB-based interface to visualize the RF decoder. The bars represent electrodes from the lower, more apical frequencies to the higher or more basal frequencies. So, for example, when I say ah, which is a low frequency vowel, more bars on the left should appear. And when I say shh, which is a high frequency consonant, the bars on the right will appear. Now, let's visualize what the output signal at the RF coil on the oscilloscope would look like. To capture the electrical stimulation, audio is recorded from the BTEs, processed through the PC, and generates a corresponding electrical stimulation that is sent back to the CCi-MOBILE. If we connect the RF coil to an Implant emulator, you can probe the electrodes you want to see. Here, you can see trains of biphasic pulses being generated. Biphasic pulses are used for electrode stimulation, as in any case of current spreading or leakage, the overcharge can be neutralized by the opposite peak of the signal. The oscilloscope can indicate the exact stimulation rate and the pulse width of the biphasic pulses. To find more on how each of the components of the platform or how to visualize the electric output, join me in the hardware breakout room at the end of this workshop.